I already uploaded few videos on the same. Might be you guys have watched that. So what is your, have you gone through the video? Yes, I'm not. Is I'm audible?
Yes, sir.
Okay. So
Yes, sir.
have you gone through the videos?
Yes, sir.
Okay. So probably you know that any differential equation is there which has a solution. A solution means a value of dependent variable which satisfies the equations, differential equation. You know what you mean by differential equation, all sort of things I already explained in the video. And the solution will contains always two parts. The first one is the complementary function, another one is a particular integral. So for the complementary functions, I already prepared the video, and you probably have learned that it will depends on the roots of auxiliary equation. And you know now how to find out the complementary function for any differential equation. Linear differential equation is given to you, isn't it? सबको पता है ना कि किसी को डाउट है कॉम्प्लीमेंट्री फंक्शन में अभी everybody gone through it how to calculate. So if I give you some problems on finding the complementary function, you are able to do that. Yes or no? Which you already did in your graduation also. Yes. आपकी आवाज आएगी तो मैं आगे बढ़ूंगा ना, अदरवाइज कैसे आए कि मैं फिर से समझाऊं आप लोगों को कि भाई कैसे करना है. यस. तो मैं किसी को प्रॉब्लम दूंगा तो वो नहीं समझा पाएगा. Means he or she cannot be able to do these examples of finding the complementary functions. Yes or no? अरे कोई आंसर तो दो भाई, तो पता चले आगे बढ़ू कि ना बढ़ू. तो मैं ऐसा समझू कि आप लोगों को सब कुछ समझ में आ रहा है. किसी को कोई प्रॉब्लम हो कॉम्प्लीमेंट आप.
सर सर कराओ ना रिपीट.
अच्छा, हैव यू बी वॉच द वीडियो?
યસ સર પણ કઈ ખબર ના પડી.
શું ખબર ના પડી એટલે what is auxiliary equation? That means you have not watched the video. बराबर. What is auxiliary equation? पहला टॉपिक છે.
સર સમજાઈ ગયું છે તમારા લેક્ચર ફર્સ્ટ લેક્ચર.
તો એક ભાઈ કે છે નથી સમજાયું. એમને જો પૂછું છું કે ભાઈ what do you mean by auxiliary equation? Okay, so if you have gone through it, જે લોકોએ વિડીયો જોયો નથી એ લોકો ફરી વખત એને જોઈ લે. મતલબ those who have not gone through it, they can go through it again and try to find out what is auxiliary equation, how to calculate the complementary function, and the same thing you did in your graduation also. So here, in this lecture, we are going to discuss about the particular integral. As I told you, in that differential equation, any differential equation of linear differential equation is of the form a0 d power n plus a1 d power n minus 1 plus a2 d power n minus 2 up to so on d sorry a n minus 1 d plus an equal to into y equal to x. So any differential equation is of this type, and when you have the auxiliary equation, as I told you what you mean by auxiliary equation, that f of d equal to 0. What is f of d? F of d is this quantity. This is the polynomial, and the roots of this polynomial will leads to the complementary function. Now here we are talking about the particular integral. So that means any differential equation which is of the form CF, that is a complementary function, in short we can write down, plus PI, the particular integral. So we have already discussed how to calculate the CF. Now in this lecture we will try to learn how to calculate the PI. Okay, so particular integral. So as I have discussed that any differential equation is, we can write down in this form, f of dy equal to x, as I already discussed, where x is a function of x, f of d is a function of d, where this, in the previous slides you can see that this a0, a1, an minus 1, all of them are constant function, constant numbers. Okay, so they are constant. And d, you know, it is d by dx. The square will be d square y by dx square. So it is a second operator, second order operator. This is first order and so on. So it is an operator, and this is all together. This is also an operator which is apply on y, and this will give you this. To calculate the particular integral, you have to write down your this differential equation in this form: y is equal to 1 upon f of d, which apply on x. So this is also an operator. Since this is an operator, this is also
સર
uh,
સર સ્ક્રીનમાં એરર આવે છે.
it's not showing.
નો.
Okay, હું white board આ લોકોનું જે બોર્ડ છે એ યુઝ કરું. Wait. હવે દેખાય છે બરાબર?
Yes, sir.
Now it's correct, બરાબર? Fine. So as I તમને ખબર પડી ને કે we have already discussed that f of d of y equal to x, which is a differential equation that can be written in the form of 1 upon f of d x. Alright? Now to get the solution, it depends on what will be the value of x. On that the differential equation is depends. Okay, what will be the solution for this? So there are different functions here. That is a different method to calculate the particular integrals. In that, we'll start with the first quantity. That is very easy to do that. Suppose your this f of d is just a d. You know that d is an operator which is d by dx. And what is the inverse operator for this? What will be the inverse of this? This is in differential operator. So inverse of that one is, yes, anybody know what is the inverse operator of the differentiation?
Sir, integral.
Integral. So there's 1 upon d, you can just replace by integral dx. So that is the quantity you will get. In the similar manner, if you have 1 upon d square, okay, of which is apply on x, then it is also 2 times integral is there. So it is integration and then again integration x dx and whole integration is there. So this is the way if your f of d is of this type. Okay. The second or third one that we need to do is 1 upon d minus a x. So instead of d, it is suppose d minus a, then this is the factor. In this situation, you can calculate your integral, particular integral in this manner, that is e power ax, then integration e power minus ax, capital X dx. So this is the formula to calculate the particular integral for the factor if it is this d minus a. See, in the previously what we have seen, your 1 upon d. So in this case, if you want to achieve the previous one, your a is 1, sorry, a is 0. If you put a is 0, this is e power 0 is 1 and e power 0 is 1 here also. So it is nothing but the integration of x, and that can be easily seen by differentiation. So here that is proof we are not discussing here. Just this is the review of the first and second order differential equation that is there. Now the fourth remark that here we need to take is your f of d, you know it is a function and it is a polynomial function, as we have seen that it is a polynomial function, and you know that the every polynomial can be factorized. Okay, that means your polynomial is an b power n plus an minus 1 b power n minus 1 up to so on a0. This is the polynomial you have, and this polynomial can be factorized into factors. Let us say the factors are d minus m1, d minus m2 up to so on d minus mn. Since it is of degree n, it has n roots. So this 1 upon f of d into x is equal to the things we can write down: d minus m1, d minus m2, d minus mn x. As we have seen here in this, if d minus a of x is there, then we can apply this way. Here also we have the same thing is there. There are 1 upon d minus, so this quantity I can rewrite as this manner. That is what we have, it is 1 upon f of d x, that we can rewrite as 1 upon d minus m1, which is operate on d minus m2, which is operate on d minus m3, and so on. Then lastly you will have d minus mn x and all the brackets. So first we have to do this calculation, and then another, and then lastly we have to do this. So in that manner you can able to calculate the particular integral for differential equation of such type for any x. Let us solve some examples so we can have the idea how to deal with such example. Okay, you know what you mean by partial fraction. Do you know what you mean by partial fraction? Anybody know what you mean by partial fraction? Anybody don't know? Okay, fine. Suppose you have a differential, suppose you have a, in this manner, 1 upon d minus m1, d minus m2, up to so on d minus mn is there. Then you can write down this fact, this expression into this form: a upon d minus m1 plus a1 upon d minus m1, a2 upon d minus m2, up to so on an upon d minus mn is there. Understood? And then you have to calculate what you mean, what is the value of a1, a2 and an Have you done such type of examples? This is called the partial fraction.
Yes, sir.
You definitely done this type of example when you are solving integral. So, for example, let us do the same example. Let's say x square minus 3x plus 2 is there. So instead of this, we have this polynomial. What is the factor of this denominator? Yes, anybody? The factor of the denominator.
x minus 2 into x minus 1.
So it is x minus 2 into x minus 1. You know the factor of this polynomial is this. Okay. Those who don't know, they can solve and do it. Verify whether the factor of this 2 will be this one is or not. Now I can write down this expression as a upon x minus 2 plus b upon x minus 1. Can I write down in this manner? Now we need to calculate the value of a and b. So for that I can write down this is as 1 equal to a into x minus 1 plus b into x minus 2. Barabar? How to calculate the value of a and b? You just substitute x is equal to 1, y x. See this expression is true for any x. So you can put any value of x here. It will satisfy. In particular, I am putting x is equal to 1. That is the easiest way to do this. Because x equal to 1, x is a factor of x minus 1 is a factor of this polynomial. So that's why I am substituting x is equal to 1 here. So this will become 0. And here you will have 1 minus 2. So that will give me minus 1. So hence the value of b will be minus 1. And if you put x is equal to 2, because that is another factor, this quantity will become non-zero and this will become 0. So it is 2 minus 2 is 0, so this quantity is 0. This is 2 minus 1, that will be 1. So your a is 1. So hence this expression you can write down, instead of a, you can write down here 1, and instead of b, you can write down here it is minus 1. This process or this expression is called the partial fraction. Have you done such a type of example?
Yes, sir.
Yes.
So let us now go back to the differential equation. Let us write down an example like this. D square y by dx square minus 3 dy by dx plus 2y equal to e power x. Suppose this is the differential equation is there. The question is to solve this differential equation. So first of all, what you have to do is you have to calculate the complementary function. So for that, I need to write down what is the auxiliary equation. Or let us write down this equation into the d form, that is d square 3 into d plus 2y equal to e power x. So this is the expression is there. We can write down. Okay. So the auxiliary equation is, so in short, the auxiliary equation can be written as e dot e is m cube minus 3m plus 2 equal to 0. Instead of d, just I have written
Sir, m square.
huh?
M square, m square.
M square, sorry. So this is m square minus 3m plus 2 equal to 0. So now we can factorize this as we already did earlier, that is m minus 2, m minus 1. They are the two factors. So therefore the value of m is 1 and 2. Both of them are real and distinct, differential. So that's why the complementary function equal to yg is equal to c1 e raised to x plus c2 e raised to 2x. ત્યાં લખાય છે, દેખાય છે તમારે?
No,
No,
sir.
sir.
સર વ્હાઇટ બોર્ડમાં બ્લેક અક્ષરોથી લખો ને.
ચોટી ગયું. हाँ तो CF equal to C1 e raised to x because M1 is 1, so that is M1x, so that is x plus C2 e power 2x. So this is the complementary function we can write down. Everybody understood how we have written this? જે લોકો વિડિયો જોયો હશે એ લોકોને ખબર પડી ગઈ હશે કે how we have written this. Okay, fine. The next task is to calculate the particular integral, that is pi. In short we can write down it is pi. So that is 1 upon d square minus 3d plus 2 into e power x, because your function x here on this side it is x, so that's why it is this. So there are two ways to do this. The one of the ways the function e raised to x is there, so that's why we can have a different method to do that, that we will also see. But here right now it is in general method we are doing, so we have to factorize this first of all. So the factor of this one is d minus 1 and d minus 2 e power x is there. Here also you can do this way. First you apply d minus 2 onto the e power x, and then you apply d minus 1 as we have seen in this quantity. So first we have apply this and then so on. In that manner also you can do this. The another way is to by taking the partial fraction. By taking the partial fraction of this. Okay. The partial fraction we already did in the previous slide. Previously આપણે આ જ પોલિનોમિયલ લીધી હતી, એનું પાર્શિયલ ફ્રેક્શન આ રીતે હતું, that we have did here. Okay. So we will use that. So this we can write down as 1 upon d minus 2 minus 1 upon d minus 1 e power x. And then this e power x, or this 1 upon d minus 2 is apply on e power x. So this is apply and this one apply. And we know that the formula for that one is d minus a e power, sorry, x will be, what is the formula? Yes, previously we have seen that we have here this e power ax integration e power minus ax into x dx. So if we apply that one here for this one which apply on x, so this will be a is here 2, so this will be 2x integration e power minus 2x into x. X is e power x, that is e power x dx, and then it is minus this operator now apply on e power x, so that's why it is again e power x integration e power minus x, because here a is 1 and capital X is e power x, so that is e power x dx. And if you solve this one, this will give you e power minus x, because e power minus 2x plus x, that will be e power minus x. And integration of e power minus x, we know that it is e power minus x upon minus 1. बराबर है? Integration of e power minus x dx is e power minus x upon minus 1. So that's why it is e power 2x into e power minus x upon minus 1. Here on this side, it is e power x as it is. Now this is e power minus x into e power x, which will be 1. And integration of 1 is x. So this will be x. Okay, so that is equal to, we can write down, this is e power 2x into e power minus x. So it will be e power x, but it is of negative sign. So it is minus e power x minus x into e power x. So that is your particular integral which we have calculated. If you want, you can common out e power x from this. So finally what you will have, it is minus of 1 plus x e power x will be the particular integral. So you can write down the solution, that is y equal to complementary function plus particular integral. The complementary function we calculated as c1 e power x plus c2 e power 2x minus 1 plus x e power x, which is the particular integral which you have. Okay, so that is the finally answer you will have. So in that manner, you can solve any example. Let me give you one more example here, and that you guys have to solve. I will not solve that one. The square y by dx square plus 5 dy by dx plus 6y equal to x. Solve this example here. Okay, so everybody have to solve this example. Open your notes and do it.
Sir, CF is equal to C1 e raised to minus 2x plus C2 e raised to minus 3x.
Okay, very good. Now find out Pi. You can find out. I will come back in 2 minutes. Yes. So anybody have done? Completed? So everybody have find out the complementary function?
Yes, sir.
Complementary function? Okay. Anybody who has not able to get that? Okay. So I understood that everybody is able to find out the complementary function. Anybody who completed the PI? Have you completed the PI? See, this is d square plus 5d plus 6 which apply on x. This is your PI. Okay. You know that the factor of this one are d plus 2 and d plus 3. These are the factor. Now we need to factorize this. The one way is already shown how to do that. You can write down this is of the form d minus or d plus 2 plus b upon d minus 3 and then d plus 3, and then you can cross multiply this LCM 1 equal to, and then substitute d equal to minus 2, d equal to 3. The another way is to do in this manner, d plus 2, you can just write down whatever the numerator here, and this d plus 3 and d plus 2 you can write down in the numerator with some gap in between. Now as you know that you required 1 here, and if I, what sign I have to put here, so this d has to be cancelled out, so obviously the sign I have to put minus, so that's why this d will cancel out, and I need 1, and you know that 3 minus 2, because this minus 1 is multiplied inside, so it is 3 minus 1, so that's why it is 1, so it will give me this expression which apply on x. So now you just factorize, means do the partial fraction, this this plus 3 is divided through this, so that means pi you will have it is 1 upon d plus 2 minus 1 upon d plus 3, which is apply on x. Now as per the formula, here what is your a? Your a is minus 2, so that's why it is e power minus 2x integration e power 2x into x dx. Here e power minus 3x, because here a is minus 3, integration e power 3x into x dx, and here you have to do the integration by parts. So you know what you mean by integration by parts? Integration of uv, u into v dx. You know this formula? U as it is, integration of v dx minus integration du by dx, that is the derivative of u, then integration of v, and whole integration is there. Okay, so that is the integration by parts. In Gujarati it's called the Khanda Samkalam. So if pi is there, you have to apply here the integration by parts by taking
સર આ રીતે કરો તો બી ચાલે અને બીજી રીતે કરો તો ચાલે.
easy રીતે એટલે
1 upon d plus 2 into 1 upon d plus 3, તો પહેલા 1 upon d plus 3 નું કરીએ અને પછી 1 upon d plus 2 નું કરીએ તો ચાલે.
ચાલો.
એમાં કઈ રીતે કે 3 કોમન કાઢીએ તો 1 plus d by 3, તો એને ઉપર લઈ જઈએ તો ઇન્વર્સ વાળું સૂત્ર લાગે ને 1 minus d ની minus 1 વાળું.
લાગે, પણ હજુ સુધી મેં શીખવાડ્યું
ઓકે સર, ઓકે ઓકે.
એ તમે શીખ્યા હશો બીએસસી ની અંદર 100%, but I am not assuming that you guys have learned that.
ઓકે સર, ઓકે.
Okay, so now by doing the integration by parts, by taking this is as u and this is as v, we can write pi equal to e power minus 2x inside bracket x as it is, u as it is, integration of v, that is e power 2x upon 2 minus integration derivative of x, which is 1, then integration of v, that is e power 2x upon 2 dx, then minus, because of this minus sign, e power minus 3x x as it is, e power 3x upon 3 minus integration e power 3x upon 3 dx. Now, can you complete the further calculation yourself? No. Okay. So the next thing, what you have to do is e power minus 2x. Again, you can integrate this, that is e power 2x upon 4. And e power minus 2x is, let me write down in two steps, no problem. So you will have e power minus 2x as it is, this is pi, into e power 2x upon 2 minus x, sorry, x नहीं आया ना, x तो नहीं आया, x see this x into e power 2x is there, then the integration of e power 2x, that is e power 2x upon 4, so it is e power e power 2x upon 4 minus, so this is bracket over, it is e power minus 3x, x into e power 3x upon 3 minus e power 3x upon 9 in the similar manner. Now with this e power 2x you can multiply inside. So that's why you will have x upon 2 minus 1 by 4, and this e power minus 3x will multiply inside, so it is minus x upon 3 and minus minus plus 1 upon 9. Now can you do the further calculation yourself?
Yes, sir.
Okay, fine. So in that manner you can have the pi. So what is your solution now? What will be your solution? What is y equal to? Y equal to CF plus EI. That is your y. CF we already calculated. That is C1 e power minus 2x plus C2 e power minus 3x. And pi, what is the final answer for pi we have?
x minus 1 by 6.
X minus 1 by 6. Everybody got this?
Sir, x minus 1 whole by 6.
Everybody got this? You can check. મોટી વસ્તુ નથી, આનું ને આનું સબટ્રેક્શન, આનું નાનું સબટ્રેક્શન કરો. બરાબર, એ તો કરી શકે, બધા જ કરી શકશે. એ ના કરી શકો તો તમારી દાન જ નથી કરવાની, એનો મતલબ એવો થાય. Fine.
Sir, it is x by 6 minus 5 by 36.
Yes, sir. Yes, sir.
x by 6 minus
5/36.
I don't know. મેં કેલ્ક્યુલેશન નથી કર્યું બરાબર છે તો તમે જે કહો છો એ હું લખીશ.
Yes, sir. It's 5/36. My bad.
X by 6 minus 5 by 36. બરાબર.
Yes, sir.
Okay, now the next task is to shortcut. In this method which we are calculating, in that what is the problem when you have a function, trigonometric function is there or any other function is there, you every time you have to go through the integral. Okay, and it is a very lengthy process to calculate the particular integral. So now we are trying to learn and see the previous method, which is we have in this manner, that is pi is to by this formula 1 upon d minus a e power ax integration e power minus ax into x dx. In this manner, in this method, any x is there, then you can able to solve this, find out this pi. કોઈ પણ x આપ્યો હોય અને જો ઇન્ટિગ્રેબલ હોય આવડું આ ક્વોન્ટિટી, આ જે ક્વોન્ટિટી છે e power ax into x, જો ઇન્ટિગ્રેબલ હોય, if it is integrable, then you are able to calculate what is the pi for that function. But every time it is not possible to have such thing. એ દરેક વખતે ઇન્ટિગ્રેબલ હોય એવું જરૂર નથી. Plus it is very lengthy. It is long, time-taking process. So what is the shortcut is to calculate the particular integral. When you have your Rx, that is your x. So if you have a different x, then use a different method. If your x is e power x, that means your function is e power x, then you can calculate your particular integral in this manner. You know that particular integral is equal to 1 upon f of d into x, but x is e power x in particular. So whenever this situation is there, the solution or the particular integral is just f of a e power x if f of d is non-zero. If f of a is non-zero, that means this is non-zero, then this is your PA. See, many a times I have found that the students are making a mistake by writing this. What is that? It is, this is an operator, and this is applied on e power x. So many a times I have found that in the answer books, the students are writing in this manner, e power ax into 1 upon f of d. And there is nothing written on this side. See, this expression have no meaning. It has no meaning. Because alone 1 upon f of d, if you write, then it has no meaning. There is no meaning of writing 1 upon f of, because this is an operator, and that operator is applying on some function. So please do this and make a habit of writing in this manner only, because otherwise it reflects that you have not understood this thing. Fine. So what is the situation? You just need to replace your d by a. You just replace d by a, you will have this, provided this f of a is non-zero. So what will happen? What you have to do if f of a is 0? If f of a is 0, then you can write down your pi as in this manner. That is x upon p dash f dash of a e power ax. So what is f dash? Is the derivative. You multiply x into e power ax upon f dash of a. If f of a is also 0 and f dash of a is also 0, okay. If both this situation is there, f dash of a is also 0, then what will be the pi? See, this is provided f dash of a is obviously, if it is non-zero, then and only then we can write down as a pi this. If both these quantities are 0, then pi can be written as x square upon f double dash a e power x, and so on. If this derivative is non-zero, then we can write, if it is 0, then it is x cube upon f triple dash, that means third derivative at a e power x, and so on. In that manner, you can find out the particular integral. For example, suppose the question is to calculate the particular integral for this e power ax. The question is to calculate this quantity. See, one way is we have did in the previous lead, that is factorize this denominator and then use that integral formula. So another way is, now we have a shortcut here. Here we have a shortcut. So what is that shortcut says? It says that if your x is e power ax, then you can write down 1 upon f of a e power ax if provided f of a is non-zero. What is f of d here? That is d square minus 3d plus 2. You just substitute d equal to 1. It will be 1 minus 3 plus 2. But this is 0. So you cannot write down that as a particular integral. So if f of a is 0, then why I have put it d equal to 1? Because here this quantity is 1. Here x, coefficient of x is 1. So for that we have this, that is x upon f dash of a e power ax. So I need to calculate what is f dash of this. That is the derivative of this quantity. So you know that the derivative of f of d, that is 2d with respect to d minus 3. This is the derivative, and you just check that f dash of d at 1, that is 2 minus 3, which is minus 1, which is non-zero. So that means the solution, or we can say the particular integral for this one is x into e power x upon minus 1. So that is the particular integral. You can write down directly. This is a shortcut for writing. Okay, can I give you one example? So let us write down.
Yes.
Okay. Let us give you one example. 1 upon d power 4 plus 1 e power minus x. Find pi. The question is this. Try to solve this yourself. આટલી બધી વાર ના લાગે ભાઈ.
1 by 2 e power minus x.
બરાબર. So answer is 1 by 2 e power minus x. Why? Because this is your f of d. And what is your a? A is minus 1. You just substitute minus 1 here. This is non-zero because it is 2. So the answer is 1 by 2 e power minus x. That is your particular integral. Barabar? Fine. The next thing is your x is sin x, sin ax, or cos ax, if any of this trigonometric function is there. Actually, I can say ax plus b પણ લખી શકાય. Here is also ax plus b. So your particular integral for function this type of function, that is 1 upon f of d sin ax plus b. So this f of d function I can also write down in the form of d square. I can write down this function is of the form d square function. Okay. It is the same thing, sin ax plus b. See, whatever the application applicable for sin, the same applicable for cos also. Cos માટે પણ same થશે. Now, whenever d is there, what you have to replace is minus a square. See, there is a different meaning of minus of a square and minus a square. આ બંનેનો different meaning છે. બરાબર? This quantity is always positive and this quantity is always negative. So it is minus 1 into a square is there. It is not minus a whole square. A quantity nothing. बराबर? A quantity है. Minus into a square. So you have to replace this square by minus a square into this. Provided this pi of a square minus a square is non-zero. जो non-zero होय तो. If it is 0, then you have to deal in the different manner. अगर 0 છે તો જ આ થાય. If it is 0, for example, pi of minus a square is 0, then you have to do your particular integral is 1 upon x upon, not 1 upon, x upon pi dash minus a square into sin ax plus b, provided this is non-zero. If pi dash of minus a square is non-zero. If it is 0, then again you have to do the second derivative. So if this pi dash minus a square is 0, then pi will be x square upon pi double dash minus a square sin ax plus b, provided this is non-zero. बराबर? In similar manner it will goes on. Let's solve some example. The question is to calculate the pi for this d plus 1 y equal to sine 2x plus 3. Barabar? So pi you can calculate by writing in this manner. So as I told you, what you have to do is d square is replaced by minus a square. So a here it is 2. What you have to do is d square is replaced by minus a square. Since a is 2, so this will be minus 4. So d square is replaced by minus 4. So it is 1 upon minus 4 plus 1, which is non-zero. So that's why this is the answer for this. That is 1 upon minus 3 sine 2x plus 3. That is your particular integral. Let's solve one more example. D square plus 4 y equal to sine 2x plus 3. See, if it is sine or cos, the method will not be changed. Method will be remain same. Okay. What you will do is you have to calculate the pi, which is 1 upon d square plus 4 sine 2x plus 3. Here, if you replace d square by minus a square, and you know that a is 2, so it will be minus 4. If you replace that one, this quantity will become 0. So whenever f of d square is 0 or phi of d square is 0, you have to differentiate this with respect to d. If you differentiate this with respect to d, this will be 2d. बराबर? અને x આવશે ઉપર. So it is x upon 2d sine 2x plus 3. This will done in two ways. આને બે રીતે કરી શકાય. એક તો આપણે જોયું તો 1 upon dx હોય તો શું કરવાનું? What you have to do if it is 1 upon dx?
Integration.
So this is integration x dx. The one way is to do in this manner. Another way is multiply and divide by d. Numerator and denominator में d multiply करो. So it is x d by 2d square sine 2x plus 3. Now you know that d square is replaced by minus 4 because a is 2. So that's why it is x upon, this is minus 4 into 2, so it is minus 8 d of sine 2x plus 3. बराबर ने? अब d of sine 2x plus 3 એટલે d means a derivative of sine, which will be cos. So it is x into minus 8 into cos 2x plus 3 into 2, the derivative of 2x plus 3, that is 2. So finally, what is the answer? X upon minus 4 cos 2x plus 3 is your final answer you will have. So can I give you one more example here? Let me give you. Solve this. D square plus 2d plus 1 y equal to cos x. That means here the question is to calculate only pi. We are not concentrating on complementary function for now. To calculate pi for this.
One by two sin x.
Very good. Only one person is able to do this.
Yes, 7/2 sin x.
બરાબર. Everybody done this? કોઈને પ્રોબ્લેમ છે તો હું કરું અહીં. No one has a problem? બધાને આવડે છે. Fine, let's use you one more. dq plus 1 y equal to sin x. Question is to calculate pi. Yes? Anyone have done this? See, in this one, you have to, what you have to do, you just write down 1 upon d cube, you can write down as d square into d plus 1 sin x. Can you write down in this manner, pi? Because instead of dq, you can write down d square into d. I will just replace d square by minus 1. Minus 1, why? Because d square is replaced by minus a square. A is 1 here, but is minus 1.
So cos x by 2.
Huh?
Cos x by 2.
No, that is not the answer. So this is minus 1, so it is minus d plus 1 sin x. Now this is the same thing which we have did, 1 upon d minus a x. What is the formula to do this? E power ax integration e power minus ax into x dx. એક આ રીતે કરી શકાય. બરાબર? Agree? Instead of x you have sin x. And what is your a? Minus 1. You minus common લઈ લો. અથવા x ને minus x લઈ લો. તો એક આ રીતે થઈ શકે ને? The another way is I am showing here. You just multiply and divide by its opposite sign, that is 1 plus d. વડે તમે multiply કરી દો અને divide કરી દો. કેમ? કારણ કે we have 1 minus d square માં. બરાબર? અને sin function છે એટલે d square આવી ગયું. So this is 1 plus d upon 1 minus d square sin x. I will just replace d square by -1. બરાબર. So this will, what will be this quantity? આ શું થશે?
sin x plus cos x upon 2.
Here right now it is 1 by 2 because it is 1 plus minus 1. બરાબર. Minus of minus 1, so it is 1 by 2, and 1 plus d, which is apply on sin x. 1 into sin x, it is sin x, plus d of sin x, that is the derivative of sin x, which is cos x. So 1 by 2 sin x plus cos x is your answer. Barabar? That is your PI. So now I think so you are able to solve many examples of such type. The third one, that is, if your x is of the power x raised to m, or it is of any polynomial of this type, a0 plus a1x up to so on a m x power m, कोई polynomial हो या type, your x. So 1 upon f of d x, whenever it is of polynomial type, then you can able to write down that polynomial, this polynomial, as 1 plus p of d. For example, आपके पास है d square plus 3d plus 4. તમારે આને આ ફોર્મમાં લખવું હોય તો કેવી રીતે લખી શકાય? 4 વડે ડિવાઈડ કરી દો આને અને મલ્ટીપ્લાય કરી દો. So 4 into d square plus 3d upon 4 plus 1. આ રીતે લખી શકાય. So instead of that, what we have is, this is your p of d, and 1 plus p of d, and 1 by 4 extra we have there. So this expression I can rewrite in this expression 1 plus p of d, and you know that 1 upon 1 plus r ની series expansion ખબર છે? What is the series expansion of 1 upon 1 plus r? અને બીજું મારે પૂછવું છે 1 upon 1 minus r. What is the series expansion of this two? Or Taylor series expansion?
Sir, 1 upon 1 plus r ની થશે 1 minus r plus r square minus r cube and so on.
બરાબર. અને 1 upon 1 minus r માં બધી પ્લસ સાઇન આવશે. Now, once you have, this is the factor of this type, then you can expand this factor in this manner, and then you apply or differentiate. Let us solve some example and so we can understand that. Let's say this example is d square plus 3d plus 2 y equal to x square minus 2x. Barabar? Here I have seen that your x is a polynomial type. That's why it is 1 upon f of d is there into x square minus 2x is there. So that I can rewrite as d square plus 3d plus 2, which apply on x square minus 2x. Now, I can take 2 common. So this quantity we can write down as 2 into d square plus 3d upon 2 plus 1 into x square minus 2x. बराबर? 3d. So it is of the form 1 plus p of d. This is your p of d. And we know that 1 plus r no formula શું છે? 1 minus r plus r square minus r cube and so on. This is the form you have. So this I can write down as 1 by 2, 1 minus d square plus 3d by 2 plus d square plus 3d by 2 square and so on, which apply on x square minus 2x. So it is 1 by 2. Now this 1 is apply on this, so it is x square minus 2x is as it is. Now this d square plus 3d by 2 is apply on this. What do you mean by d square? d square નો મતલબ શું થાય?
2 times derivatives.
2 times derivative. So we have to differentiate this quantity 2 times. So the first time derivative is 2x minus 2x. बराबर? Sorry. 2x minus 2. That is your first time derivative. આનું ડેરિવેટિવ કરો પહેલી વખત શું આવશે? 2x minus 2. બીજી વખત શું આવશે? 2. અને થર્ડ ટાઈમ 0. એટલે all the derivative beyond 3 is 0. તો અહીંયા સેકન્ડ ટાઈમ ડેરિવેટિવ છે પહેલી ટર્મ. So it is minus 1 by 2 as it is. આ by 2 છે એમનેમ રહેશે. Inside bracket second time derivative એટલે 2 plus 3 into 2x minus 2 એ એનું ડેરિવેટિવ છે. અહીંયા d સ્ક્વેર આનો સ્ક્વેર છે, તો આમાં કેવી ટાઈપની ટર્મ્સ આવશે એ ખાલી તમારે જોવું પડશે. તો this is of the form a plus b square, બરાબર? a square plus b square plus 2ab. તો આનો સ્ક્વેર કરશો એટલે d પાવર 4 વાળી ટર્મ આવશે. d પાવર 4 કારણ કે અહીંયા સેકન્ડ ડેરિવેટિવ 2 છે તો થર્ડ ડેરિવેટિવ 0 થાય એટલે d પાવર 4 એટલે ફોર્થ ડેરિવેટિવ 0 થશે. લાસ્ટ ટર્મ જે છે એ 9d સ્ક્વેર આવશે by 2. So એ ટર્મ આવશે પ્લસ 9 by 2 d સ્ક્વેર એટલે 2 એનું સેકન્ડ ટાઈમ ડેરિવેટિવ 2. બરાબર ને? સમજણ પડે છે ને? અને મિડલ ટર્મ જે છે that is 2ab. 2ab is a middle term. તો અહીંયા મિડલ ટર્મ શું થશે? 6d cube. બટ ક્યુબ છે તો સેકન્ડ ડેરિવેટિવ ઇઝ 2, તો થર્ડ ડેરિવેટિવ પણ 0 થશે. તો એ પણ ટર્મ 0 આવશે. અને આગળના જે બધા આવશે એ પાવર 3 છે. પાવર 3 માં એક પણ ટર્મ થર્ડ ડિગ્રી કરતા નાની નહીં, બધી થર્ડ ડિગ્રી અથવા ફોર્થ ડિગ્રીની ટર્મ્સ હશે. એટલે આગળના બધા જ ટર્મ 0 થશે. એટલે આન્સર આવું આવશે. આનું સિમ્પ્લિફિકેશન એ કરી શકશો તમે?
Yes, sir.
Okay. So in that manner you can able to calculate if your, let me give you one example here. Find out EI for this example.
Sir, it's homework or we'll do now?
It is homework.
Okay, sir.
Okay. So we'll stopping here. See all the class notes which I have explained here. It is available on my website. You probably go to the Moodle and the link for the website is also available there. તો આ જે ક્લાસ નોટ છે ને મારી એ ત્યાંથી તમને મળી રહેશે બરાબર. those who have not gone through it, just go through it. અને now from now every day I will conduct 2 hours, 2:30 to 4:30. So please be prepared for that from tomorrow. બરાબર છે?
ઓકે સર.
Fine. So
લેક્ચરના રેકોર્ડિંગ વિડિયો બી મળશે.
લેક્ચર રેકોર્ડ થયો છે તો મળી જશે.
સર તમે કરો ને એટલે એની લિંક મોકલી દેજો.
ઓકે. બરાબર. See you then. Can leave the meeting.